Hi, I am Sai Krishna. Now I'm going to give my seminar on of STLD subject based on flip-flops. My topic is flip-flops. Now I will explain in a detailed way of flip-flops. Introduction of flip-flops. Flip-flops are basically sequential logic circuits used to store binary information. We can store binary information in the flip-flops only. Flip-flops are not combinational circuit. It is a sequential circuit, and it is used to store binary, and it can store one bit of data and building blocks of memory and registers. And for flip-flops we will have memory sorry for flip-flops we will have clock and two inputs and two outputs, that are present state and next step, and two inputs are, then we have many types of flip-flops we will see in the next slide. And this is introduction of flip-flops. Flip-flops are basically used to flip-flops are sequential circuit used to store the memory, used to store the information of binary. A flip-flop is a bistable multiplicator, and the two states are 0 and 1. And if the clock changes when the control signal is applied. Okay, now I explain about it. When we are having the clock signal as 1, the flip-flop will on. When we are having clock signal as 0, the flip-flop will not work. This is the first condition we have to learn about the flip-flops. We are having two inputs and one clock input. When clock input is high, then the flip-flop on, and then the flip-flop will work, and then the flip-flop will store the information. If the clock is 0, the flip-flop doesn't on and doesn't work. Importance of flip-flops. These flip-flops. Okay, now I explained about flip-flops and introduction of flip-flops. Now I am going to explain about flip-flops are important. These flip-flops are why are important. We are having some memory element of flip-flops, and these flip-flops are used in many things like counters, registers, and memory units. Essential for synchronized in data systems, and a fundamental element in sequential logic design. These flip-flops are used to store elements, and these importance are sometimes the element changes, sorry, the memory changes. By using master slave, we will save all the memory, and this is for synchronous circuits. We use the flip-flops, fundamental elements in the sequential logic design, and this is the importance of the flip-flop. Basic principle of flip-flop. Flip-flop stores the data and input signal and clock signal pulses. The output depends on the present input, but also on the previous state. Okay, the output depends. The output means we are having next state output. Now the output depends upon input and present state. These both, depending on these both, and the output is coming for the flip-flop. And we clock is also important for the flip-flop. Clock is high, then the flip-flop will on, and clock is low, the flip-flop doesn't on. This is the basic thing we should learn about flip-flop. Classifications of flip-flops. We are having four types of flip-flop. First one is SR flip-flop. SR flip-flop means set and reset flip-flop, and these flip-flop is used in many ways, and these flip-flops are used in counters, registers, and etc synchronous circuits. And these signals, these SR flip-flop is positive edge trigger, and second one is JK flip-flop. JK flip-flop also is used to store the elements, and flip-flop means to store the data, and JK flip-flop. And D flip-flop. D flip-flop in the sense data or delay flip-flop. If we give any information, it comes out, but it delays some time. So it is called data flip-flop. And we are having T flip-flop. T flip-flop means toggling flip-flop. Toggle means what? When 0 comes and 1 comes, I mean, the values are increasing alternatively and decreasing alternatively. First value is 0, second value is 1, and third value is 0, and fourth value is 1. All clocks of the devices are different input characteristics. And I'm saying about the flip-flops are used to store the elements. We are having four types of flip-flops: set, reset flip-flop, and data or delay flip-flop, and toggle flip-flop. Now we will see about the Here we can see SR flip-flop. SR flip-flop is in a simple form and input S is set and R is reset and Q is present state and Q bar is next state and mean it is a complement of Q statement. When we are having R and S values, I mean it is a two combinational circuit means we are having two inputs. Two input means we can give in four ways. I mean 2 power to 4, 0 0 and 0 1 and 1 0 and 1 1. We will see the truth table of the flip flop. Now we are seeing that SR flip-flop truth table. When we give 0 and 0, it becomes a present state and it does not, I mean, it gives a present state, means no change in the output. When we are giving 0 and 1 flip-flop, we 0 and 1 as the input of the SR flip-flop, we get 0 as the output. When we give 1 and 0 are the inputs of the SR flip-flop, we will get 1 as output. When we given 1 and 1, it is invalid and undefined state. The invalid is the major drawback. When we give both inputs are 1, the flip-flop is invalid. This is the first drawback of the SR flip-flop. By overcoming this drawback of the SR flip-flop, the JK flip-flop comes. This is about JK flip-flop. JK flip-flop is improved version of SR flip-flop and J and K. Inputs are J and K. It toggles output avoiding invalid states. Before only I said that the JK flip-flop main motto is to overcome the SR flip-flop. The drawback of SR flip-flop is when we given both inputs are 1 and 1, it is invalid. But here in the JK flip-flop, they overcome it. In JK flip-flop, we given 0 and 0 as the input and there is no change. Then we given 0 and 1 as the input of the JK flip-flop. We get output as 0 and we give 1 and 0 are the inputs of the JK flip-flop. We will get 1. Now we will see that the overcome that the JK flip-flop overcome as SR flip-flop. In SR flip-flop, 1 1 is invalid and here we give 1 1 and both inputs are 1. It toggle. We widely used in counters, registers and etc. in many of them. Now I am going to explain about D flip-flop. No drawbacks are in this D flip-flop and D flip-flop is known as data flip-flop or delay flip-flop. It has only one input and we are having the clock signal. If has single input D and clock signal, it eliminates invalid states of SR flip-flop. Now we will see the truth table of the D flip-flop. D is the input, Q is the output. 0, when we give 0, it will delay for some time and it gives the output as 0. If we give 1, it delay some time and gives output 1. The output Q is simply follows the input at every close pulse. Now I am going to say about the T flip-flop. T flip-flop is derived from the JK flip-flop. When T is 1, it toggles the output. When T equal to 0, it holds the previous state. It is commonly used in the counters. And T flip-flop truth table is T and Q next up. When we give 0, no change. When we give 1, T will toggle. I mean T become T bar. Toggling means increasing the values or alternatively. First value is 0, second value is 1. Second value is 0. Third value is 0 and fourth value is 1. This is about the T flip-flop. Applications and conclusions of the flip-flop. On first onwards, I am saying that we use these flip-flops in counters, registers, memory units, and frequencies. Flip-flops are sequential circuits data, and we use these flip-flops in counters, registers, and without these flip-flops, we cannot do some things like counters, registers. Flip-flops are the basics for the counters and registers. And this is about my seminar.